I am Dr. B. Sujata, Assistant Professor, Mathematics, Department of Science and Humanities, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to see about maxima and minima for single variables. The contents in this video includes the definition of maxima and minima, types of maxima and minima, difference between absolute and relative maxima and minima, properties of maxima and minima, and finally, how to find a critical point if a function is given. Let us see the definition of maxima and minima. Maxima and minima of a function are the largest and smallest value of the function respectively, either within a given range or on the entire domain. Maxima and minima are called the extreme points of a function. The types of maxima and minima are local or relative maxima and minima, and second one is absolute or global maxima and minima. The local or relative maxima and minima are the maximum and minimum values which is greater than or lesser than its neighbor. Whereas the absolute maxima and absolute minima is the highest or lowest value in the entire domain of the function. So this is the diagram for global maximum and global minimum and local maximum and local minimum. Let us see the difference between absolute maxima and minima and relative maxima and minima. So, absolute maxima is also called as the global maxima or global minima, whereas relative maxima and minima is called as local maxima or local minima. The absolute maxima and minima is bounded by the domain of the function. The relative maxima and minima is not bounded by the domain of the function. Absolute maxima and minima is the highest or lowest point of the function, whereas relative maxima and minima is the higher or lower among both neighbors. Absolute maxima and minima is the global peak of the curve, whereas relative maxima and minima is the local peak of the curve. Next is properties of maxima and minima. First one, there is at least one maximum and one minimum that should lie between equal values of f of x if f of x is continuous function in its domain. There is one maxima in between two minima and vice versa. Maxima and minima occur alternatively. Last one, there can only be one absolute maxima and one absolute minima over the entire domain. Next definition is critical point. A point C in the domain of a function f of x is called the critical point of x if f dash of x equal to 0 or f dash of x C does not exist. Let us see an example to find the critical points. So the problem is find all critical points of f of x equal to x power 4 minus 8x square. Here f of x is a polynomial. So its domain is all real numbers. So to find the critical point, first we have to find the derivative f dash of x. So when you differentiate the function f of x, which is x power 4 minus 8x square, we have the first derivative as 4x cube minus 16 x. Then put f dash of x equal to 0. So we have 4x cube minus 16x equal to 0. So here it is a cubic equation. So we'll be having three values for x. So 4x is common. Take it outside. So we'll be having as 4x into x square minus 4 equal to 0. So x square minus 4 can be written as x plus 2 into x minus 2. So when you equate to 0, we have it as x equal to 0, and when x plus 2 equal to 0, we have x equal to minus 2, and when x minus 2 equal to 0, we have x equal to 2. So the values of x are 0, minus 2 and 2. So to represent in the point form, we need the value of y. So put x equal to 0 in f of x. So when x is equal to 0, f of 0 equal to 0. Then put x equal to minus 2 in f of x. So we have f of minus 2 is equal to minus 2 power 4 minus 8 into minus 2 the whole square, which is equal to minus 16. Similarly, put x equal to 2 in the given function. So we have f of 2 equal to minus 16. So the critical points are minus 2 comma minus 16, 0 comma 0 and 2 comma minus 16. So to find the critical point, we have to first find f dash of x and equate to 0, and you find the values of x. Then put the values of x in the given function, will be getting the value of y. That is our critical points. Thank you.